Sir, sir, start
हाँ
करिए.
हाँ हाँ
Sir,
कर दिया yeah let us start. It
yes, sir.
is 4:15. I think it is 4:17.
Yes,
Yeah,
sir.
let us start. Yeah.
Okay. We will continue from chapter 7. Already 10 slides is already covered by Abhishek. And it is with our web services and the contemporary SWA. How all the characteristics.
You please remember this diagram. This diagram is hard, but very much necessary.
Very
Very
helpful to
much.
remember all the category of characteristics in SWA. All the SWA characteristics you can remember if you will practice it more. Here the web services and the SOAP messages are the two important things. Web service and SOAP messages and other characteristics, the other specifications, how they are interconnected with our web services and SOAP messages. Just we are going to directly to the reliable messaging part. Here you can check the reliable messaging increases the quality of services of web services. It also guarantees the delivery of failure notification of any SOAP messages. Means it provides a acknowledgement of a delivery message. Also, it is implements in the form of correlation, and the correlation is associated with other web services. Reliable messaging is also used with the addressing. So ultimately they are interconnected with each other. So all the specifications or characteristics of SOAP are interconnected with web services and SOAP messages. Then directly we'll go to the next one is your reliable messaging. You check here. The benefits of a loosely coupled messaging framework come out at the cost of a loss of control over the actual communication process. The loosely coupled means it is saying it is less dependent of any correlation among others. It is less dependent and it is the cost of a loss of control over the actual communications process. And after a web service transmit a message from sender to receiver, you are sending a message. Then it has no immediate way of knowing what type of things may arrive, whether the message successfully arrived at its intended destination, just like the ultimate destination. It will come to our mind. I sent a message. So what can be derived from our delivery of the message? Now firstly we will think whether it is properly delivered to the intended destination. Then whether the message fails to arrive or therefore requires a retransmission. If you are sending and the network will not allow you or any network issue is there, then your message delivery is failed. And if any necessary of retransmission is there, and whether a series of messages arrived in the sequence they are intended to. Let you are sending a sequence of messages, packet 1, 2, 3 up to n, and whether they have delivered in a sequential manner or not. So these are the things we have to consider while transmitting a message over a network. First, service. It is sending a message. Look at the figure 7.7. I need to know if all my messages are delivered or arrived at the intended destination. Then if delivered, then the service B will send, how about I just tell you which message I received. Then how he will know which message I have received. So there should be a proper sequence of the messages of the delivery. Then it will send an acknowledgement. That is the delivery guarantee means it is sending an acknowledgement to the sender. And check here. The RM source, reliable messaging source, the reliable messaging destination, their application source, their application destination. Okay. From the application end, we can visualize our messages. But in the physical path, what is there? Our reliable messaging source and destination, where we are transmitting. So, first, when the application source will send a message through the reliable messaging source, it will transmit through the physical path to the reliable destination message, and it will be delivered to the application destination. So, it is a standard format of sending any message with a reliable messaging technique. Means it will provide a quality of service. In the larger diagram, what I show to you, if there is a quality of service, it provides a quality of service, reliable messaging. Now the sequences, the message sequence, if the messages are delivered to the intended destination with a proper sequence, a sequence establishes the order in which message should be delivered. So a sequential number or any packet number will be assigned to each of the messages so that it will be delivered in a proper sequence. Each message that is part of a sequence is labeled with a message number or packet number. You are sending the SOAP message. So there is a SOAP message number will be properly defined for it or identified, and the position of the message within the sequence. The final message in a sequence is further tagged with a last message identifier. Let n is your last message. So in the sequence of nth message, it should be defined or identified with a last message tag, so that the receiver will define it as that it is the last message, the overall package or the ultimate package is delivered to me. Then acknowledgement. Since it is a reliable messaging, the sender will always expect an acknowledgement from the receiver. A core part of the reliable messaging framework is a notification system or your acknowledgement system that is used to communicate the conditions from the reliable message destination to source. Means it will come back from the receiver to the sender. Upon receipt of the message that containing the last message identifier, the reliable message destination issues a sequence acknowledgement. Once received, the entire message, the messages are first initially sent with some message numbers, and once the last message delivered to the destination with a last message tag, then it will prepare a sequence of acknowledgement from the receiver to the sender. The acknowledgement indicates to the reliable message source which messages were received. So it will indicate it to the reliable message source. It is up to the reliable message source to determine if the messages received are equal to the original messages are transmitted or not. So the reliable message will determine it, whether what I have sent it is properly delivered to the intended destination or the ultimate user or not. The reliable message source may retransmit any of the missing messages. So once delivered, all the n packets are delivered, and if there is any failure of in the middle of the any packages or any missing of the packages or messages, then again it will retransmit it. The particular message it will retransmit it to provide the delivery assurance. Here you can see it is sending a sequence of messages. Message 1, message 2, message 3 are delivered from reliable messaging source to destination. Means from sender to destination in a reliable messaging environment. And after receiving all the messages at the end user or the intended destination, then what will happen? It will start sending the sequence of acknowledgement. Next. A reliable messaging source does not need to wait until the RM destination receives the last message before receiving an acknowledgement. So the source will not wait for the destination receiving the last message or not. It will send the messages to the destination. Then the reliable messaging source can request that additional acknowledgement that to be transmitted at any time issuing request acknowledgement. So while sending the messages, it will request for each message, it will request a acknowledgement, but it will not wait for the acknowledgement, rather it will send until the last message delivered to it. Then at the end, it will provide a acknowledgement. A request acknowledgement sent by the reliable messaging source to the reliable message destination indicates that the RM source would like to receive an acknowledgement message before the sequence complete. So before the sequence complete, if any necessary of any acknowledgement, it will just send a request to whom? To the receiver. Now, here there is if any failure condition occurs, you are sending sequence. So first one, it is a incomplete sequence. You are sending message 1, message 2, message 3. Then if any failure occur in between that, then the sequence will be incomplete and it will again give a NAC message, that is a negative acknowledgement message, if not delivered to the end user. Again, the RM source will retransmit it. Now, some ideas about the delivery assurances. We will continue with that. The nature of a sequence is determined by a set of reliability rules that is known as your delivery assurance. Whether we have a set of reliability rules. The delivery assurance are predefined message delivery patterns that establish a set of reliability policies. Okay. The following are the set of rules. We will cover one by one. First one, at most once, means the delivery assurance promises that the delivery of 1 or 0 messages. If the rule is like at most 1, means the message delivery is maximum 1 or 0. If more than one of the same message is delivered, then the error situation or error condition will occur. Then at least once means the delivery assurance allows a message to be delivered once or several times, means one or more. But if the delivery of the messages is not there or 0 messages there, then it will create a error condition. Then the at least one delivery guarantees that only the message will be delivered at once. Actually, this one exactly once, it is not at least once. The third one is your exactly once. This is the delivery assurance guarantees that a message only be delivered once only, and error occur if 0 or multiple number of messages are delivered. The third point is exactly once. Okay. Then the in order delivery assurance. It is used to ensure that the messages are delivered in a specific sequence, just like I told earlier, in a sequential manner, M1, M2, M3, Mn. The delivery of messages out of sequence triggers an error. If the sequence is not followed, or if any failure occur in between the sequence, then it will trigger to a error condition. Note that this delivery assurance can be combined with any of the previously described situations. Hence, it can be also combined with the previous conditions. What are the previous? At most ones, at least once, and exactly once. Now, we will compare it with our SOA, reliable messaging. The reliable messaging brings to service-oriented solutions a tangible quality of service. Ultimately, from a set of characteristics, it provides the quality of service and the interoperability. It introduces a flexible system that guarantees the delivery of message sequence supported by some comprehensive fault reporting. Fault reporting means it is interoperable, and this elevates the robustness of any SOAP messaging implementation and eliminates the reliability concerns most often associated with any messaging framework. So you can check how the reliable messaging are associated with other SOAP specifications like the policies. It supports the reliable messaging, and the reliable messaging implements in the form of a correlation that guarantees the delivery or any failure notification for the SOAP messages. It increases the quality of service of the web services, and also it relies on the user address. Okay, so now we'll go for any case study with RELCO and TLS. Here, it is sending a invoice submission from Relco. It is sending a invoice submission. Means it is a request, and this request will be sent that is the invoice message transmitted with a part of sequence. Now it will be delivered to a intermediary service. What is that intermediary service? That is your load balancing service. And already I told whether it is an active one or passive. If active one, it may modify the message, or if passive one, it will not do anything with that message. So after receiving the message from the invoice service submission service, it will send it to the account payable service, and the account service, after receiving all the part of sequence, the account payable service will again return back the acknowledgement message to the invoice submission service. So after transmitting a series of invoice of messages, means it is a part of your invoice, the last message within the sequence triggers the issuance of the acknowledgement. Once the last message is delivered to the account payable service, it will trigger or allow to send the acknowledgement message by TLS. And our next one is correlation. A service-oriented communication framework. It is inherently loose coupled or loosely coupled. So there is no intrinsic mechanism for associating the messages exchanged under a common context or as a part of common activity. So since it is not intrinsic, so it is not associated with any other common context as well as any other common activity. So even the execution of a simple request response message exchange pattern MEP, request response MEP message exchange pattern, provides no built-in means of automatically associating the response message with the original request. And the correlation addresses this issue by requiring that related messages contain some common value. If any related messages are there, they have some common values, and that services can identify to establish their relationship with each other or with overall task they are participating. So if there is an issue by requiring the related message that can contain some common value, then that can be identified, and their relationship will be identified with each other and overall tasks they are participating. The specifications that realize this simple concept provide some different manners of implementation. So different category of different realization of the implementation depends on their specifications. Now the correlation. The service A, the sender, it is saying to the service B, the receiver, that B, I am stateless. Who is stateless? State service A is stateless. So I need to have a way of knowing that your response related to my request. Okay. Then when it is sending the message, it is written, relax guys, I have got it covered. So the service B is also saying, I am also stateless too. So how do you expect me to do this? So in this case, both are stateless. So how the message exchange will occur in between service A and B? So the correlation places the association of message exchanges into the hand of the message itself. So there will be a association of message exchanges into the hand of message itself. So, and the correlation in our orchestration. Orchestration means a proper arrangement or a proper management of all the important tools. So the BPL orchestrations, web service BPL orchestrations need to concern themselves with the correlation messages between process and partner services. Okay. So it need to concern themselves with the correlation of messages between process and partner service. In between process, there is a partner service, and you have the process, and there should be a proper message exchange correlation. And this involves the added complexity of representing specific process. Also, it has some complexity for representing the particular or specific process instances within the correlation vector. Further complicating this scenario is the fact that a single message may participate in multiple contexts. We are also sometimes feel that a single message or a single packet is participate in different contexts, and that is identified by a separate correlation value. If the situation is like that, then we have to identify with a separate correlation value. So to facilitate these requirements, the WSBPL specification defines the specific syntax that allows for the correlation of extensible correlation sets. Okay, so to provide the facility, then the WSBPL specification will be defined for the specific syntax. If you need any specific syntax for providing the correlation value for multiple contexts, so it will create it and the extensive correlation set will be associated. These message properties can be dynamically added, deleted, or changed to reflect a wide variety of message exchange scenarios and environments. Okay, so after correlation also we have the policies. The use of policies, it allows the service to express the various characteristics and preferences and keeps it from having implementation and enforce rules and constructs in a custom. So policies means you have to follow the rules, you have to follow the guidelines, you have to implement and enforce the rules and constraints in a customer manner from the corner of the customer or the customer. It adds an important layer of abstraction where you can abstract the important content. Allows the service property to be independently managed, where you can manage it, all the service properties to be managed independently and to follow the guidelines or policies. See here, the service A again is sender sending to a request to service B to send me the data, but this response is hold on there, you have to follow my rules first. But the rules and the construct defined by service B, it has to be followed by service A. So the policies can express a variety of service properties, including the rules. Then in the policy framework, three things are there. One is your WS policy attachments, and the WS policy assertions. Okay, in the XML format of how to define it in the entire message, the policy description, the policy alternative, policy assertion type A or B, then the policy assertion type C or D. This is the basic structure of any policy description.
Not audible, sir.
Right now, I am audible. Hello, am I audible or not?
Yes, sir. Now
Yes,
you are
yes, yes.
Okay, we're continuing. So, three extensions in the WS policy: the WS policy itself, and the policy attachments, and the policy assertions. And this framework is comprised of the following things. Now, the policies can be programmatically accessed. The guidelines or any rules or constants, whatever we have included in our policies, that should be accessed programmatically to provide the service requesters with an understanding of the requirements, restriction of service providers at runtime. So during the runtime, what the guidelines and the conditions to be followed by the service requester, it should be provided through the programmatic way. So alternatively, policies can be studied by humans at design time. So also these policies should be studied by the humans during the design of any software development. The service requests are designed to interact with the specific service providers. Now, the assertions and the policy alternatives. The service properties expressed by a policy description are represented individually by the policy assertions. What is the policy assertions? Assertions means a set of policies, a specific number of policies that is defined by some particular rule. So, and that policy assertions described in the form of some one or more policies. The examples of policy assertions include the service characteristics, their preferences, capabilities, requirements, and the rules. Already we have told this thing. And some are defined as optional and some are defined as mandatory. The policy assertions can be grouped into policy alternatives. Okay. So means if you are not able to follow the one guideline, then you have to follow the another. Like when you are accessing through your password. If you are forgetting the password, you have to access it through the one-time password. If you are forgetting your password, then you have to access it through one-time password, any date of birth or any guidelines. What is defined in the policy. And this gives a service provider the ability to offer the service requester for a choice of policy so that they can follow a choice or options. Now, the assertion types and the vocabularies. The policy assertions can be further categorized from their types. And that types are associated with some specific XSD schema. So how these are categorized or defined with some XSD schemas, XML schema definitions. In the same manner as XML vocabularies are defined in XML schemas, the policy vocabularies simply represent the collection of policies within a given policy. So similar to the XML vocabulary, which is defined in the XML schema, the policy vocabulary is also collected in that manner. That's just like it is a XML vocabulary. Similarly, a policy alternative vocabulary refers to the policy types that is contained within a specific policy alternative. So, what it is saying, now a alternative vocabulary that also refers to a policy types that is within a particular or specific policy alternative. Means if you have a lot of choices or options, then you can also alternate it. Then the policy is in orchestration and choreography. The policies can be applied to just about any subject that are part of orchestration or choreography. For example, if a policy establishes various requirements, then orchestration partner services and choreography partners helps to interact with each other. Okay, so they just apply to any subject as a part of orchestration or choreography. Now, how the policies are associated with our SOA? So, what are the important components who are associated with policies? If in SOA is a setting, then the policy are certainly the laws, regulations, their guidelines that has to be maintained for that setting. And so, what are the rules you are following inside a city? If you think or SOA in the aspect of a city. So, policies are a necessary requirement for building the enterprise level service-oriented environments. So, it helps for building an enterprise level service-oriented environment, and also that provides a means of communicating constants, rules, guidelines, whatever you think about it. As a result, they improve the overall quality of the loosely coupled arrangement of service. If the policies will be proper, and if the policies are if there are alternatives to the policies, then their loosely coupled arrangement can be possible for any requirement. See to the 7.21 figure here how the policies are associated. So the metadata exchange that standardizes the retrievals of policies. And the policies support the reliable message. It also uses the addressing and it provides the metadata for the web services. And also it includes supporting the loose coupling, interoperability, reusability, discoverability, as well as quality of service. Okay. So how they are associated. Then the next one is your metadata exchange. If you will remember the figure whichever I shown in the very first slide. So that will help to understand all the components associated with your web services as well as the SOAP messages. Okay, come to the metadata exchange part. Here the metadata describes what other endpoints need to know to interact with. So what other endpoints associated with metadata should be interacted. So specifically the web service policy that describes the capability requirement and the general characteristics of web services. So metadata exchange, service requesters ask what they want to know about the service provider. So if they have a information to know about all the requirements from the service provider. Now service A is sending a message with the information that I have heard of you, tell me more about you. So here then the service B will send a response with here you go, my life story is there. It will just provide the metadata for it if properly authorized and if it is following the all rules described by service B. Now the specifications of metadata exchange. The specification essentially allows for a service requester to request a standardized request message. Means if you are sending messages to a particular receiver and it is sending a particular type of messages. See, so for that you have to send a message according to his standard. So for different organizations, you have to follow different standards. So while sending a message, it has to follow it has to issue a standardized request message that is defined by that respective receiver or the ultimate destination. In other words, if a service requester knows where a service provider is located, it can use the metadata exchange to request all service description documents that comprise the service contract by sending a metadata exchange request to the service provider. Okay. So in the metadata exchange, it is also an extension of the web services, and the specifications are defined as follows: like get the WSDL, get the schema, get policy, and get the metadata. First, you have to know the WSDL, the web service definition language defined by the intended destination. Then get the schema, then get the policies, and then get the metadata. And for all that things, you have to send a standard request message defined by the intended destination. Now, the request message and the response message for the metadata. Okay. We'll just see a XML code for it. How you are sending, this is the format of sending a request message. You can check the line 7, the get metadata request. Okay. After the enveloping technique, means you are sending through a SOAP messaging. So there is an enveloping technique, and inside the enveloping technique, there is a get metadata request message. And the next slide is your the response message. Again, it is inside the envelope. So the request and response message of metadata exchange. So here a service requester uses the metadata exchange to programmatically request. What have we told? So during runtime, it is requesting for the metadata as a programmatic view, and that is available in the metadata documents associated with any web services. So to do this, it must issue a get metadata request message. So To get it or to do this or to process it with, it has to send a get metadata request, and this kicks off a standardized request. So it will send a standardized request and response MEP resulting in the delivery of a get metadata response. So once the get metadata request is delivered to the intended destination, it can expect a response of MEP metadata exchange. Okay, so here is what happens for a metadata retrieval activity to successfully complete, or how it will be completed successfully. A service requester issues the get metadata request message, and it is in a standard format. And this message can request a specific type of service description document, whether that is your WSDL or XSD schema or any policy. It has to follow all the guidelines or all the specific description what is defined by the intended destination, and it can simply request that available metadata, then it will be delivered. The get metadata request message is retrieved at the endpoint to which it is delivered. Ultimately, it will be delivered to the endpoint from which it is received. The requested metadata information is documented in the get metadata response. So all the stories or all the information or all the contents will be documented properly within a SOAP envelope, and it will send a response message. This is your get metadata response message. Now, the get metadata response message is delivered to the service requester. Okay, so the contents of the message can consist of actual metadata contents, address reference of the documents, or a combination of both. So once it is delivered to the requester, it may be a actual metadata document or any reference to the document or the combination of both. Just like you are sending a request mail to send me a paper PDF. So someone is attaching the PDF, someone is sending the link of the PDF, and someone is sending you the link as well as the PDF attachment tool. Okay. So this is the format of sending a request from the sender side, and this is the response format. Next is a sample of sending a metadata request. One is your requester, service requester, sending a message with proper messaging format, or that is your standardized messaging format. And after checking all the policies, guidelines, whether it is followed by the requester or not, then the service provider will send the metadata response, and it includes the WSDL document or any XSD schema documents or any address or reference of the policy documents. Here in the get response, it will provide the, when you are asking for a metadata request, and if you are not following the destination or service provider's message, policies, then what will happen? Before accessing the metadata of the service provider, you have to follow the policies. So for that, you have to request for the policy document and follow the policies properly and request for the metadata about the service provider. Now, the metadata, how it is associated with our SOAP. Its ability to automate the retrieval of meta information reinforces loose coupling between the services. So it helps to retrieve the meta information or to retrieve the metadata by the loose coupling between the services. Where is loose coupling between the services means the services are less dependent and increases the ability for service requesters to learn more about available service. So it again requests the ability of service requesters to learn more about service provider. By standardizing the access to and retrieval of metadata, service requesters can programmatically query a multiple of candidate providers because enough service provider metadata can more easily to be retrieved and developed. Okay, so you will go through it properly, and the overall discovery process is improved, and the likelihood for services to be reused is increased. So in the metadata, how it is associated with other components of our service-oriented architecture. Okay. The metadata exchange is enabled by the standardized swap message. First, we have to standardize the message according to the service provider's policy, rules, and guidelines. Then the metadata exchange standardizes the sharing of metadata between the web services. Just like I told, the service requester will have to learn about the available service providers. So it will standardize the sharing of metadata between all the service providers or web services. The metadata exchange uses the addressing and also standardizes the retrieval policies. And it supports the characteristics of loose coupling, interoperability, usability, discoverability, and quality of service. Now with the case study with Relco and TLS. To know about the TLS account payable service, the invoice submission service of Relco will send a get metadata request message, and which will be delivered first to the intermediary service provider's load, that is your load balancing service. And load balancing service will send the message to the account payable service. And the response will come if everything will be followed properly. Then only it will send a invoice submission service that will be delivered to account payable service. So first the request, then we will get the response. Again it will send the invoice submission message. And this is the revised Relco invoice submission process. Now includes a periodic metadata exchange with TLS. Now the important part is your security. It is another aspect of SOA associated with both web services as well as the SOAP messages. The SOAP messaging communication framework upon which the contemporary SOA is built emphasizes some particular aspects of security that needs to be accommodated by a security framework. Ultimately, you need a security framework to emphasize the communication framework in our contemporary SOA. So a list of security specifications are defined below, and for more information regarding the specification, we have to cover all the web service extensions, WS star extensions. First is your WS security. It is also a web service. Then the WS security policies. It is another web service. WS security trust. Then WS secure conversion. WS federation. Then XSCML, extensible access control markup language. Then XRML, extensible rights markup language. XML key management. Then XML signature, XML encryption. Then security assertion markup language, then .NET passport, it is another security framework. Then the SSL, very popular one, secured socket layer. Then the WSI basic security profile, web service interoperability, WSI basic security profile. So these are a list of specifications mainly used for our contemporary SOA communication framework. Okay, so we need a security framework for the contemporary SOA. First one, three things like your identification, authentication, and authorization. Three things one by one we have to know it. And in so we have in our security CIA, the confidentiality, integrity, and the availability. So another part is identification, authentication, and authorization. First one is your identification. So for a service requester to access a secured service provider, once we are incorporating the security framework to our communication network within the contemporary SOA, we have to follow all the security policies. And for this, the service requester has to access a secured service provider, and it must first provide the information that explains its original. When you are accessing any secured web service, what you are doing, you have to accessing through any web service, sorry, username or passwords or an FTP means any security framework should be incorporated for the say service provider or the server, and this referred to as making a claim. So claims are represented by identification information. You are claiming that you are the authorized person. So how you will claim it? You have to show your identity, then it will allow you. So this identification information are stored in the SOAP header. When you are sending a SOAP messages, this identity, where it is available in the SOAP header, and the web service security, the WS security establishes a standardized header block. You have a body part and a header part, and in the header part you should have the identity of your information for which you are designed, at which point it is referred to as tagging. So in the figure 7.27, the sender is requesting to the receiver or recipient, and in the message header it should have the identity. Now the authorization. Now the authentication. The authentication requires that a message being delivered to it be received prove that the message in fact from the sender or not. You have to be authenticated whether this information or this identity is from the actual sender or not. So for this, the service must provide a proof of its claimed identity, whether it is true or not. So it will check the identity, whether it is received from the desired sender or not, or who is the genuine one or who is the authenticated one, whether it is delivered from that sender or not. Now the authorization. Authorization means it determines the what extent the authentication is. See, here the sender is allowed it. Here the sender is identified. Here the sender is authenticated. But up to what extent it has the accessible limits. In the server, it is a vast, wide range of accessible elements or wide range of sources. But it does not mean that it will provide all the accessibility facility to the sender. So for this, it will define the limit of the authorization, up to what extent he is authorized. Then single sign-on, a form of central security. Central security means here we have to access for once, and sorry, here we have to be checked your security part once and allowed it for access then longer time. So because services are autonomous and independent from each other, services are independent and autonomous. So a mechanism is required to persist the security context established after a requester has been authenticated. Otherwise, the requester would need to re-authenticate itself with every subsequent request. So if you are performing n number of tasks within the website or any service provider, so for any task, if you will be allowed for re-authenticate again and again, it will always hectic, and you may not work out properly with your proper requirement. So for that, you need a single sign-on address, and after that, you will be allowed to access all the things. So and this uses a single sign-on technology that allows a service requester to be authenticated once, and then it has its security context information shared with other services, and the requester will access without further authentication. So no need of any re-authentication once authenticated. It will be again allowed with other service providers, and you will access directly from there. Okay. So another three primary extensions which are very important in the single sign-on concept, that is your SAML, security assertion markup language, and the important framework, security framework is your .NET Passport, and the XSCML, XML access control markup language. So these are very much helpful in our single sign-on process, where you have to be authenticated once and then access with all the information shared by other services, rather re-authenticating repeatedly. Now, as an example of a single sign-on technology that supports centralized authentication and authorization, let's briefly discuss some fundamental concepts associated with your SAML. Okay, so it implements a single sign-on system in which the point of contact for a service requester can also act as an issuing authority. So in this single sign-on process or system, the point of contact of a service requester acts as an issuing authority, means the authority will pass you a token, and showing that token you will be allowed it to access the required resources or informations. This permits the underlying logic of that service not only to authenticate and authorize the service requester, also it assures that the other services or that service requester has attended this level of clearance. So this token or this issuing authority's access will help the service requester that in which level he has the authentication level or the authorization level. Other services that the service requester contacts therefore don't need to perform any authentication or any authorization steps. Instead, upon receiving a request, they simply contact the issuing authority to ask for the authentication and authorization clearance it is originally obtained. So, rather instead of performing the authentication and authorization step, the service provider will directly contact to the issuing authority, and that issuing authority will provide the level of clearance or provide the authorization or authentication clearance which is originally provided. The issuing authority provides this information in the form of some assertions, means a set of rules, set of policies that communicate the security details. Now, a basic message exchange pattern with our SAML. Now, the service requester will send a request message. First one, the service request sending a request to the service provider, and that service provider is the issuing authority. Now, the issuing authority will provide a authentication card or authentication tokens to the service requester. Okay, then when the SOAP messages will be requested from the service provider, another service provider, then what will happen? The service provider, and that is your SOAP information, sorry, where the informations are available, that will direct access to the issuing authority. And if the issuing authority will allow it or permit it, yes or no, then the service requester from the left side in the figure you can check, that will directly access the service provider and no need to go for any re-authentication again and again. Okay. Next one is your confidentiality. It includes the privacy or any concealment of a message, information or content. Means ultimately we are protecting our privacy. That is the confidentiality. A message is considered to have remained confidential if no service or agent in its message path are not any authorized to do so for viewing the contents. Okay, so in the path of message, there must not be any unauthorized person, or there must not be any agent or any unauthorized services, so that we can say that is our contents are confidential and providing or protecting our privacy. The confidentiality means that the privacy of the message has been protected throughout the message. Okay. Now the next one is your integrity. Integrity means the data should be changed. The message should be changed by the proper authority, or data should be updated. What you are doing, transactions, and it should be updated or changed properly by a authenticated person or a genuine person. So integrity ensures a message has not been altered. What it is saying, a message must not be altered, and if altered, it should be with a authorized one, and its departure from the original sender. This guarantees that the state of the message contents remains intact from the time of transmission to the point of delivery. Has the message, when the sender is sending a message, it should contain, has the message changed since it's sent or not. Now the transport level security, where we have a SSL secured socket layer, and the message level security and transport level security. You heard about the point-to-point encryption and the end-to-end encryption. Okay, transport means you have transport level security means you are providing security to the channel. You have providing security to the message path. But message level security means you are providing the security to the particular message by any means of encryption or by means of any encoding techniques. So the secured socket layer runs above the TCP/IP and below high-level applications. It has the HTTP, Hypertext Transfer Protocol, LDAP, the Lightweight Directory Access Protocol, and the IMAP, Internet Message Access Protocol. And this type of technology used to protect a message that is determined to extent to which the message remains protected while making its way through it. Okay. First thing, transport level security means to providing the security to the path or to the channel, and message level means to provide the security to the message. Okay. Now the security socket layers. Secure socket layer. For example, if it is a very popular means of securing the HTTP channel upon which the request and response are transmitted. However, within a web service-based communication framework, it can only protect a message during the transmission between service endpoints. Hence, SSL only efforts of transport level security. Then, what does the SSL consume? It has the server authentication, then the client authentication, that is optional one, and an encrypted SSL connection with confidentiality. And this protects against the electronic eavesdropper. Okay. So who are eavesdropper means who are listening to us or who are listening to our confidential informations without the knowledge of what? The senders or the sender, in between the sender and requester. Then integrity, and this part, this protects against hackers. Now, the transport level security. The service requester is sending the message in a protected path or protected channel to the intermediate service. The intermediate service is not protected, and it is sending to the service provider, and the path is again protected. So the transport level security only protects the message during the transit between the service endpoints. And where is the service endpoints? In between the service requester and service intermediary. That path is protected, but the intermediary service is not protected. So it provides a security during the transit in between the service endpoints. Now, if for example a service intermediary takes possession of a message, it still may have the ability to alter its contents. Now, if the intermediate service is not protected, so it has the chance that it can alternate the contents. So to ensure that a message is fully protected along its entire path, then message level security is required. So in this context, what we are doing, we are providing protection to the message directly, so that in the entire path, the message will be secured. So in this case, the security measures are applied to the message itself, not to the transport channel or not to any message label. So now, regardless of where the message may travel, but the security is applied with the message itself. and also it provides a end-to-end message protection. Now encryption and digital signature. The message level confidentiality for an XML-based messaging format such as SOAP can be realized through the user specification that comprise the WA security framework. In this section, we focus on XML encryption and XML signature, two of the more important WA security extensions. Okay, which one? The XML encryption and XML signature. These are very important things in the aspect of XML documentation, and that ensures the confidentiality as well as integrity of a message. Here the digital signature means XML signature. Digital signature means you are sending your signature digital, you are sending a message file and then you are sending a digital signature file. Okay, so in the XML encryption, an encryption technology designed for use within the XML, and it's cornerstone part of the WA security framework. Okay, so entirely the XML document is encrypted, and it provides the features with which encryption can be applied to an entire message or only to specific part of the message. Okay. So we are encrypting that part of our message if there is any important contents are there. If we have a huge story and there are no use of that story, no need to encrypt the entire XML document. But if we have some important contents within that story, like your credit card or debit card PIN or credit card debit card number within your story or within your information or content, then what you have to do? You have to encrypt only the password part. You have to encrypt only the PIN or credit card part, credit card number part. No need to apply the encryption to the entire message. Better go for the specific part of the message, just like your password, PIN, OTP, whatever. OTP, PIN. So, to ensure message integrity, a technology is required that is capable of verifying that the message received by a service is authentic, in that it has been altered in any manner since it is passed. Already I told what is integrity it is saying. Now we are verifying that if the message is modified in the middle of the transmission, so we have to verify it, and if it is sent by the fast sender, then XML signature provides the features that allow for an XML document to be accompanied by a specific algorithm driven piece of information. So just like it is your digital signature, your piece of information where your digital signs is included with the content or a document, and that document is your XML document, and this signature is tied with the content of the document, so that verification of the signature by receiving service only will succeed if the content has remained unaltered. So the verification will be successful without a failure if it is properly, the sign is properly verified. If the sign is scratched or scrambled, or if the sign is altered, then the content of the documents are what? Changed or modified. Now the header part and body part. In the header part, it is encrypted with, and the signature are there, that is your digital signature signing the documents, and in the body part we are encrypting the specific part of the contents which are important to the sender or receiver. A digitally signed submessage containing the encrypted data. Now the security with our SOA, how it is associated. The message level security can clearly become a core component of service oriented solutions. So rather providing the transport level security, the message level security become a core component of our SOA, and these security measures can be layered over any message, and this security measure can be applied over any layer of message. Any layer of message means to the specific part or the entire message, or to, and the security measures can be layered over any message of transmissions to either protect the message contents of the message recipient. And the WA security framework and its accompanying specifications therefore fulfill the fundamental quality of service requirements that enable the enterprises to utilize the service-oriented solutions. So how the security is associated with other components? First, the policies. Policies can implement the security assurance for the security, and the security protects the SOAP messages, and also it prevents the misuse of web services. Ultimately, it provides the quality of service. The important thing is the quality of service.
Therefore, you open that slide number 1, first slide. How this security is associated. You
Yes,
show
sir.
them. Yeah. You just see how security is associated in this figure. Yeah. Always remember this figure. This figure is always associated with every problem of SWA. Every problem of SWA. Security problem, how? Just they show it.
Yes,
Yeah.
sir. In the security, for the security part, the policies can implement the security assurance. First, our policies should assure the what the in our standard what the security measures should be incorporated. And once it is incorporated, the security will be defined, and that security will protect the SOAP messages, and also it prevents the misuse of web services. You can follow the arrows. Okay, the security, how it is protecting the messages and
Look at the security. Where is the policy? Look at policy, how it is connected.
police will first assure
What are
the
the,
what type of security should be incorporated in for their standards.
so you so that the way you, oh, you don't know how to use the marker. The way you try to learn how to use the marker, okay? So that okay. Next. Therefore, this is
Then the diagram
important.
is this
Uh,
one.
Next class
Here, in this
we'll
diagram,
talk.
it is
Uh,
given how the security is associated with other parts of our
you
SOAP.
see how 3 important policies, SOAP message, and web
Web service.
services. How these 4 are associated with security part of SWA, and
Yes.
that is the main quality aspect of SWA.
Service.
Quality
It provides the quality of service.
quality of service. Until unless you have the quality, nobody will appreciate it, nobody will use it. So you have to maintain the quality. So to maintain the quality, what are the parameters? How you have to fix up the policy, you have to look at the messages, look at the various services. So that figure is the main figure, and these are the sub figure from that main
These
figure.
are the
Okay,
part of that larger figure, sir. These are the
larger
part.
figure. Okay, you close it there. Take the attendance.
Sir, only 6
Yeah.
slides are there.
Oh, you want to finish it?
Yes, sir.
Now
Only
what?
6.
Okay.
Remaining 6, sir. Remaining 6.
For this
सर
chapter. अच्छा,
सर
okay,
छोटा है
chao.
सर, देखिए तो फोन कर
Okay.
सर नहीं सर चलो.
Okay.
Then the last one is your notification and eventing. Okay, it is also another. You can also check in the larger figure, the large figure. So here a service A, it is interested with something that happened. Let me know. Means service B has a lot of notification or lot of interesting things going to happen. So for this, the service A will send a request to service B of that if something is interesting happens, let me. If anything important or anything that is helpful for me, let me know. So it will send a okay later. So it will send a message. Later, service A will not request anything to service B. Only the service B will send the notifications. Just like previously we have studied about the subscriber and policies. Publisher, subscribe and publish. If anything important is with service B, it will send to service A. So once subscribe, the service B A is notified with anything with service B that publishes according to the interest of service A. A subscriber is the part of the application that submits the subscribe request message to the notification producer. And this means that the subscriber is not necessarily the recipient of the notification messages transmitted by the notification producer. Okay, same thing it is defined here. So the subscriber will first send a request message to the publisher. Okay, and it will send a response message to it. and the notification consumer will continuously send the notification which is desired by the subscriber. And both the subscriber and notification consumer roles can be assumed by a single web service. So both will be in a single web service. That is, the notification consumer means that will receive the notifications from the publisher. And the subscriber is considered the service requester. Now the notification broker in between both the publisher and subscriber, what happens? Sometimes we have a broker. So we are not directly contacting to the publisher, rather we are accessing it through a broker. The broker will provide the notification to us. And the notification broker is a web service that acts on behalf of the publisher. So to perform the role of the notification producer. And this isolates the publisher from any contact with subscriber. It will isolate us from the publisher. So in between the publisher and subscriber, who is there? There is a broker. And that broker will deal with us directly. Note that when this notification broker receives a notification message from the publisher, once the message is received by the publisher to whom? To the broker, it temporarily assumes the role of notification consumer. Then it will assume as a notification consumer, which was with the subscriber. So temporarily it will behave as a notification consumer. And the publisher registration manager is there, which is a web service that provides an interface for subscriber to search through and locate items available for registration. And this role may be assumed by the notification broker. In the diagram you can understand. And the next slide I'm going to it. And the subscription manager is a web service that allows the notification producers to access and retrieve the required subscription information for a given notification for broadcast. So if it is allowed the subscription information for a notification that to be broadcasted, and this role can be assumed by either the notification producer or any dedicated third-party service provider. Now, here the publisher is in another part. We are not directly, here means the subscriber is not directly interacting with the publisher. So in between all, there is a notification broker, and which temporarily acts as a then very fast. From the very first you check it, the subscriber, it will send a subscription request to whom? A registration manager. That will register your subscription request. Then who is there? The publisher registration manager. That will just register your subscription request. Okay. Now that subscription the publication register manager will send the message to the notification broker, who is directly communicating with the publisher, and that notification broker will receive the message or receive the notification from the publisher, and it is act as a notification producer. So once it is received from the publisher, it will behave as a publisher by the subscription manager, and the notification broker will send the message to the notification consumer. Okay. And also to other notification consumers, a lot of n number of notification consumers are there. It will send through the brokers only. So your subscriber has to first register through a publisher registration manager. And once it is registered, it will be interacted with the notification broker, and the notification broker is the one who is sending the notification message after receiving it from the publisher. So it is a basic eventing architecture. Again, we have some event source and event sink. Event source means it is sending the events to the event sink, and these events are their notification events. An event sink, sometimes also called as a listener. No request will be sent from the event sink. It is only just like a listener, and it is a piece of coding that defines how a server or computer to be handled in a given event. So the first case in the subscription manager, it will just request the message with a subscribe request containing a subscription filter, what type of message to be given. It is optional to it, and then it will send a request for that subscription message with a subscribe request containing a subscriber filter to the event source, and it will send the notification message. Okay. Now, the notification eventing with the SOA concept. By implementing a message label capable of supporting the traditional publish subscribe functionality, the corresponding legacy features now can be fully realized within the service-oriented architecture. Okay, so in the notification and eventing, it uses the addressing and also it provides the publish and subscribe model for web services, and it supports the characteristics of composability as well as your quality of service. Okay, the notification and eventing establish a standardized policy and subscribe model within the SOA environment. Now, it is considered with our RELCO and a TLS concept. Here, the new RELCO subscription service allows the RELCO to receive notification from the TLS system notification service. So first, the TLS notification service will provide a service request. Sorry, the RELCO will provide a request, that is the TLS service subscription service to the system notification service of TLS. Now it will provide a response, then notification message will come with a series. Okay. First you have to request and you will get a response of subscription message, then notification will come to the RELCO. Okay, so here the request notification on the following topics, that is your metadata change to TLS account payable service or any metadata change to TLS purchase order service. So the notification will come from the system notification service of TLS. Okay. So these are some parts with our web service with the contemporary SOA and their architecture, how they are supporting all the SOA components, how they are supporting with the loose coupling, composability, interoperability, reusability, extensibility, vendor diversity, discoverability, and quality of service. Okay.
And Deba, you assign randomly 4% for presentation on Thursday. 4%.
Yes.
Any topic, signature, anything, any this security parameters. Okay.
Security. Yes.
You look at that to assign randomly 4%. Or you give
Right
four
side
important topics. Let everybody come prepared. You call them randomly. Okay.
Yes, sir.
Yeah. Let everybody prepare.
I'm just sending to all the students about the 4 important topics of security, and randomly we'll pick on Thursday.
Yeah, randomly we'll pick on. So boys, you will be getting a mail from Deba Bhaiya today that these 4 are the important aspects under security. He works in the area of security. So he has a very good knowledge on security and how it is linked with the SOA. So you will assign some 4 topics and everybody come prepared with different slides. Will show your talent and you will pick randomly and you have to present on Thursday. So Thursday it will be a little bit delayed. So come prepared with all your slides. No excuse for anybody. Okay? Okay, that's all. So
Yes,
there will be little bit delay on Thursday also because you all have to show your talent with examples. Okay, take attendance, Deva. Okay, take attendance.
Yes, sir.
Yeah.
Sir, already
So
downloaded.
already downloaded. 17
Just
are present.
downloaded.
Okay. 17 are present.
Yes, sir.
Asutosh is absent. Asutosh is absent. Asutosh?
Yes.
Yes. आशुतोष ये प्रतीक आशुतोष का क्या हालत है क्या कैसे क्या है हाउ इज आशुतोष प्रतीक अग्रवाल
Yes, sir. So he's saying like he's not able to attend classes. Means
क्यों क्या हो
not
रहा है
means breathing problems.
ओह ये सितंबर से ब्रीदिंग प्रॉब्लम उसका कंटिन्यू हो रहा है अच्छा अरे मैंने लॉन्ग सी जेबिली अफेक्टेड अच्छा ओह He
Sir,
should.
because of the corona, sir.
Yeah, because of the corona, yeah. Oh, so much, such a long time. He's affected since September. Acha,
Yes, sir.
Hare. So he should go to a good hospital where the lung specialist will be there.
Yes,
Hmm.
sir. Yes, sir.
Yeah.
And between means I think in Christmas holidays means
Uh-huh.
he was hospitalized.
ओ ओ ओ कभी कभी किसको किसको बहुत जोर से पकड़ लेता है अरे अरे भगवान उसको ठीक कर दे अरे अरे बहुत जोर से किस किस को पकड़ लेते बट ही हैज टू बी वेरी केयरफुल एंड meet the right doctor that Remdesivir is he might have been given that Remdesivir but it might not be working with him that may be the problem उसको पूछना प्रतीक कि रामडेसिविर की सलाइन इंजेक्शन लगी थी रामडेसिविर ओके
Yes, sir.
देख लो नेट में देख लो रामडेसिविर की 100 ml सलाइन का साथ मिक्स करके इंजेक्शन दी जाती है दैट इज दी स्टैंडर्ड मेडिसिन फॉर द लंग्स प्रॉब्लम बिकॉज ऑफ कोरोना ये ट्रम्प वगैरह को हुआ था सबको ये रेमडेसिविर दी जाती है सलाइन का साथ उसको पूछो तो जरा ठीक है तो लॉन्ग्स
Yes,
इज
sir.
अफेक्ट लॉन्ग्स इज अफेक्ट ओके जरा पूछो जरा बीच बीच में बी इन टच विथ हिम ओके सो दैट ही शुड बी aware that we are there in the background okay okay
Yes.
okay so who else is absent Deba who else another
Sir,
boy is absent who else
just, sir, it is in the download folder.
Anyway, okay. So we have strength is 19 plus 2, 21. We are 19 present today. Okay, that's okay. I don't bother and care. I appreciate any sincerity. That's the all my interest in it. Okay, Deba. That's all.
Yes.
I am leaving.
Just, sir,
Well,
just a, one second.
yeah.
1 second. Sir.
And you will be having lab tomorrow at 9 o'clock. Okay. 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 Okay, Deba. You call me in intercom after the class. Okay. Okay.
Sir.
Okay, I'm leaving. Okay, bye.
Vidya,
Bye,
sir,
student.
20.
Vidyasagar is
Sir,
present
left
today.
and again joined after 12 minutes.
उसका कुछ problem है. He is having some virus. This problem है. He is suffering. Okay, Deva. Okay, I'm
Yes.
quitting.
Yes, sir.